How did a conversation with an AI help solve a decade-long physical riddle? For years, scientists have studied jamming, but there was one aspect that resisted being demonstrated: the relationship between the exponent of holes and the exponents of forces. This relationship describes how a material behaves right on the edge of the jam. Recently, a team led by Giorgio Parisi managed to prove that both exponents add up to 1. The finding is significant, not only because of the result, but also because of its origin. The first version of the test did not arise from a slate, but from a conversation with Claude, a model of artificial intelligence language. This raises questions about the role of AI in scientific research. Jamming is a phenomenon that is well known qualitatively, but accurately predicting the exact point at which a material stops flowing has been a challenge. The equations necessary to describe this behavior have been elusive for years, which has frustrated many physicists. The solution to this problem was found in the equations of scaling fullRSB, which describe the breakdown of symmetry in disordered systems. Although the community suspected that the relationship between the exponents was true, no one had been able to demonstrate it rigorously until now. The conjecture that led to the solution was not a traditional calculation, but an idea that arose during a working session with Claude. Although the initial response contained errors, the intuition behind it was key to advancing the demonstration. This case illustrates how artificial intelligence can contribute to science, not solving problems directly, but providing new directions and strategies that researchers can explore. Claude offered a way to address the problem that no one had ever considered before. The authors of the study took Claude's guess and developed it in a rigorous demonstration, closing the gaps that the original version had left open. The final result was surprising, since the relation to plus b equals 1 turned out to be simpler than had been anticipated. However, it is important not to celebrate the victory too soon. Although identity has been demonstrated in the fullRSB framework, its extension to other regimes of statistical physics remains an open challenge. The scientific community continues to wonder if this approach can be replicated with other problems. This advance is not an isolated case. It adds to other recent attempts to use artificial intelligence in the generation of mathematical conjecture and theoretical physics. The question now is whether the next big solution will also start with a conversation with an AI. Research on jamming and artificial intelligence is in its early stages, and the future promises more discoveries. Could AI be the key to solving problems that have been stuck for years?